Hello students, welcome to LG Institute of Engineering and Technology. Here myself, Mr. Jaswal Kishan from Civil Engineering Department, and we are learning all about earthquake engineering. So let's start our today's session. So in today's session, we will be proceeding towards an example. Let's have a look. So these are the basic steps. So here, calculate the base shear for the 7-story RC building, which is hospital building located in Bhuj, using seismic coefficient method for the following data. So here it is an hospital building, so important building, and it is located in Bhuj, so the zone will be our 5. Now number of bays in x direction is 6, number of bays in y direction is 4. So there are 6 bays in x direction, 1, 2, 3, 4, 5, 6. 1, 2, 3 and 4. 4 bays in y direction. Bay width is 4 meter, so each bay is having the width of 4 meter. Story height means story to story height is given, floor to floor height is given 3.5 meter. Thickness of particular slab means the floor slab is having 150 mm. Size of the beam is 230 mm cross 450 mm. So here it is a drawn of the beam 450 mm and width is 230 mm. Size of column is 300 mm cross 600 mm. So 300 cross 600 mm. Live load is 4 meter. Live load is 4 kN per meter square. Internal wall thickness is 115 mm. External wall thickness is 230 mm. Assume suitable data. Give calculation with appropriate clause number of ISO. Now here, dead load is not given. In the previously solved sum, there was some value given for the dead load. Now here, the big task is that we need to find out the dead load of the entire building of 7 story. So just that is the critical or say important part of the sum for the solving. So please make sure you have a great focus to get to know. Now here I will be giving some data. So look, building base is of 16 meter. So here it is in 16 meter and length is of 24 meter. Floor height given, number of story given. Direction in which the earthquake is coming is not given, so we have assumed in the long direction, which is 24 meter. Slab thickness is 0.15 meter as it is given in mm. Building situated in zone 5. Imposed load, live load is given 4 kN per meter square. Now here certain data need to be assumed, like as if there is a floor, there will be a floor finish, and if in the roof or say terrace, there will be floor finish plus waterproofing. So certain data has been assumed as terrace waterproofing is 1.5 kN per meter square. Floor finish is 0.8 kN per meter square. You can assume as a 1 also. Density of concrete. Now here concrete density is assumed to be 25 kN per meter cube and density of masonry is considered as 20 kN per meter cube. So this data you need to be assumed. Now here floor area. So it will be the entire length into the width. So it is coming out to be 24 multiplied by 16 is 384 meter square. Now number of floors without terrace is 6. So this is just a basic data and certain assumption which was required for the calculation of dead load. Now look, this basic data I am keeping aside for the reference for the solving of the next steps. So look, step number 1, which was lumped masses of various floors level. So here this step has been changed because the dead load is not given. So we will be calculating step by step of the building and entire load. Now first of all, weight of typical slab floor means without floor, means without excluding terrace, the remaining floor weight will be how much? It will be the area of the entire floor multiplied by its self weight, addition of floor finish. So what it is, the area of the entire slab multiplied by self weight plus floor finish. Floor finish weight will also count. Now here self weight will be 25 multiplied by 0.1. 25 is the density of the concrete as the floor will be made up of concrete. So density of concrete multiplied by its thickness. So it will be getting the self weight plus floor finish we have assumed 0.8. And floor area we have already calculated is 384. So 384 multiplied by 25 into 0.5 plus 0.8. After solving this, I will be getting the floor area, floor load will be 1747.2 kilonewton. So this is the weight of the particular floor. If we consider a terrace, then there will be addition of this waterproofing, as it is an topmost portion which is likely to affected by the rain or say water. So addition with the waterproofing we need to apply. So floor finish plus waterproofing. So here waterproofing we have assumed as 1.5 kilonewton per meter square. So here remaining portion will be same, just an addition of waterproofing. So 384 multiplied by 25 into 0.15 plus 0.8 plus 1.5. So we'll be getting me 23.2. 2323.2 kilonewton. So what we did, we just did floor area multiplied by self-weight plus floor finish for the floors, and for the roof waterproofing is also added. So this we have calculated the weight of floor and roof. Next is we need to calculate the beams. So there are two types of beams, longitudinal beams as well as transverse beam. So first is longitudinal. So how we will be calculating it? So it will be number of beams into length of that particular beam multiplied by self weight of the beam. So first we will be calculating the self weight of the beam per meter length. So this is the self weight of the beam per meter length is 0.23 multiplied by 0.45. So here it is then area of the beam multiplied by it will be of concrete, so it has been assumed as 25. So after solving this, we will be getting 2.588 kN per meter, as it is for per meter length. So self weight we have calculated. Now number of beams. How many number of beams are there? So look, 1, 2, 3, 4, 5 and 6. 6 number of beams in 4, 5. So there are 5 lines. So 1, 2, 3, 4 and 5. There are 5 lines of longitudinal beam and there are 6 number of beams in particular line. So 6 multiplied by 5, these are the number of beams multiplied by this length of the beam. So look, how much the length of the beam will you take? Now here 4 minus 0.3 minus 0.3 has been done. Why? Look here, column has been placed in particular position. This is 600 mm and this is 300 mm. So this is 0.6 meter and this is 0.3 meter. So the beam will be of shorter of the column. Means there is a column if there is a 5 meter length and there is a column at the end. So beam will be not at that particular portion. It will be somewhat shorter than that entire length because there is a position of column. So beam will be of cut to cut length only. So this entire 4 meter minus this 0.3 and this 0.3, both sides, because this will be present over here also. So there is a 4 meter length minus 0.3 of this side minus 0.3 of this side. So it's the actual length of the beam multiplied by its self weight. So we can get the weight of the longitudinal beam. Similarly, the weight of the transverse beam. So for the weight of the transverse beam, now just the difference is this length of the column will be differ. Now here it is in 300 mm, so it will be 0.15 and 0.15 for both the sides. So there are 4 number of beams in particular line, and there are 1, 2, 3, 4, 5, 6 and 7. So there are 7 lines in transverse beam. So 4 multiplied by 7 multiplied by 4 minus actual length is 4 meter, but we will be reducing this length. So minus 0.15 minus 0.15 on both the sides multiply by 2.588, which is nothing but self weight of the beam. So we will be getting 268.1 kN. So this is the calculation of beam. Previously we did floor, which is of roof also and or the different floor also. Then we have calculated for this number of longitudinal beams and number of transverse beams. Now we will be calculating weight of parapet wall, which will be at the top on the roof. So for that it will be perimeter multiplied by thickness multiplied by density. So as this parapet wall will be at the round of this entire terrace, so the perimeter will be 2 multiplied by 24. Why 2 multiplied by 24? So look, there are 6 beams and here it is a 4 beams. So here 6 4s are 24 multiplied by 2 both sides and here four number of beam of 4 meter, so 16 meter over here and 16 meter over here. So that's why 2 multiplied by 16 and 2 multiplied by 24. 24 meter length is over here and 16 meter length is over here. So the addition of this entire length multiplied by thickness. So we'll be taking 0.115 mm thickness of say short say internal wall thickness similarly, and multiply by density. So now then it will be made up of masonry, so density of masonry will be 20. So the value is coming out to be 184 kilonewton per meter. So this is the weight of parapet wall. Now weight of external wall per meter height. So where will be external wall? So at the ends only there will be external wall. So what we did? We did floors, we did beams, we did parapet wall. Now we are going to external wall. So again it's perimeter. So into thickness into density. So here this thickness into density is over here. So now perimeter, how will you calculate? So 6 number of beams and multiply by 2 both the side. So 6 to the 12. Now what will be the length? So the length will be similar as we were deducting in the beams. We also deduct in the walls also, because the column will be placing over here also. So there will be deduction of this length. So it will be 4 minus 0.3 minus 0.3 in this longitudinal direction, plus 2 multiplied by 4, as there are 4 number of days over here and on the both the side. So 2 multiplied by 4, multiply by 4 minus this thickness, again the smaller side one, so 0.15 minus 0.15. Multiply by thickness is 0.323, so the external wall thickness is 230 mm, so 0.23 meter multiply by 20, as we have assumed masonry density as 20. So it will be coming out to be 323.8 kN per meter. Now next is weight of internal wall per meter height. So we'll be calculating the weight of internal wall also. So we'll be excluding the external walls and remaining are my internal walls. So first of all, length of longitudinal wall. So there are 1, 2, 3, 4, 5 and 6. 6 into 3 lines. So 6 multiplied by 3 into the length. Length will be 4 meter minus, similarly we will be neglecting the length of this column. So 4 meter actual length minus length of column. So there are 6 number of days into 3 lines into the total length. Plus similarly for transverse wall, so there are 1, 2, 3 and 4. There are 4 number of days into 1, 2, 3, 4, 5 lines. So 4 multiplied by 5. Multiplied by the length will be 4 minus 0.15 minus 0.15, as this is 300 mm. So this is in meter. Actually it is 150 mm. Multiply by thickness. So internal wall thickness we have 115 mm. So it is in meter. Multiply by density of masonry is 20. So after calculating it, we will be getting the weight of internal wall. Now weight of column per meter height. So this column will be located at each point. So there are 1, 2, 3, 4, 5, 6 and 7 points at 1, 2, 3, 4 and 5 lines. So 7 5s are 35 number of columns. Multiply by area. So 0.6 multiplied by 0.3 is its area. Multiply by density of column is 25, because it is of concrete column. So density of concrete is 25. So this is for per meter height. The actual length is 7 multiplied by 3.5, which is, so this is for per meter length. So the per meter length is 157.5 kN per meter. Now the next further step is imposed load. So the imposed load on the roof is 0 and our live load is given 4 kN per meter square. So for that we have to take only 50%. So it will be 2 and the area is 384. So 384 multiplied by 2 is nothing but 768 kN is our live load. Now this is an lumped mass of roof and lumped mass of floor. Now take an important note that here this how it need to be calculated. So dead load plus live load. Now here for roof, which are the dead loads will be coming? So this is a dead load for roof, plus this is an dead load for longitudinal beams, this is for dead load of transverse beam, plus this is my parapet wall. Now look, I'll be showing you what we have taken is, so what we have calculated. So this are my weight of roof, then we are taking weight of longitudinal and transverse beam, and we have took the weight of parapet. Now what about walls? So as walls are the below to the roof level and internal walls also as well as column, so how much length of that particular walls, external wall, internal wall and column need to be taken? So in clause 7.4 it has been written that any weight support in between storage shall be distributed to floors above and below in inverse proportion. So in the very first session of this code, I have explained that the formula or say the way to calculate the weight is half, if this is my floor, half of the weight of above one and half of the weight of the below one will be calculated. But in the roof, it is a topmost portion, so below half portion will be only considered. So this is an external wall weight into 3.5 meter is my height minus 0.45 is the width of or say depth of beam. So 3.5 minus depth of beam, so it is an actual length of the wall divided by 2 because half will be considered on roof and half will be considered at the bottom. So I would like to repeat again, this is an external wall weight. The 3.5 length is the story height minus the width or say depth of this beam divided by 2 because half we are only considering. Similarly for internal wall plus this is the weight of column. So 157.50 is particular weight into 3.5 meter length divided by 2. Now here we are not taking beam because it is an actual column only. So 3.5 divided by 2. So this is the actual weight plus 0 is my line load because on roof there is no line load. I would like to repeat again, this is the roof, this is a longitudinal beam, transverse beam, parapet wall, external wall, internal wall and this column. Everything we have took. So after solving it, I am getting my lump mass of roof is 4282.89 kg. Now lump mass of floor, similar to this, but we will be not doing this divided by 2 because half of the bottom one and half of the top one will be considered as a full portion. So look what we are doing. This is the dead load of particular floor. This is a longitudinal beam. This is a transverse beam, and this is an 323. Now here parapet wall weight will not come because it's on roof only. So this 323 multiplied by 3.5 is floor height minus 0.45 is depth of beam. So we are not doing divided by 2 because half, this is a floor, half of top one and half of bottom is coming to be full portion. So that's why we are not doing divided by 2. Similarly for internal wall, similarly for column because half of top column and half of bottom column has been considered. Plus 768 is my live load. So I will be getting this lump mass of floor. Now there are 6 number of floors and 1 roof. So 6 multiplied by floor weight plus roof is getting me a total weight of the entire building. So this is the new step which you have learned. Please revise twice or thrice to take a knowledge of how to calculate the weight. Now next of the steps are same. Look, this is a time period, so 0.09 h divided by root d. So now here d has been considered as the longer side direction, so it will be 24. So divided by root d 0.09 h, so we will be getting my TA as 0.45. Similarly, next step is design seismic shear. I am going fast because I know that we have did it number of times. So AH into W, AH is Z by 2, I by R, SA by G. Z is my zone, so it is in zone 5, so factor is 0.36. Importance factor is 1.5 because it is an hospital building. R is reduction factor, so for 5. Now next step is SA by G. So average response acceleration coefficient. So 1 by D. Because our time period or say nature time period is coming out to be 0.45. For hard rock soil it is coming out to be 0.45. So for hard rocky soil it will be in between this limit. So our value will be 1 by T, and T is nothing but our nature time period. So natural time period is this one, 0.45. So 1 divided by 0.45, I'll be getting 2.222. Now after getting all the value, I'll be keeping in AH. So after getting AH, I'll be calculating VB, and then VB will be distributed along the vertical height. So there are 7 number of storing. This is the weight of the roof, and remaining are my floors. So this is an respective height. So this is an Wi into HI the whole square. This is a summation of it. Its value Wi into HI the whole square. This is the value. Divided by this, I'll be getting 0.294. Similarly, the rest of the value can be calculated. Now for QI, this multiplied by VB. So 0.294 multiplied by 4497.91, I'll be getting this. Similarly for this, we can find out. So this is my QI, and now VI is nothing but this plus this plus this equals to this plus this equals to this plus this equals to this, and similarly as on. So now this is an basic step which we have read in previously, and at last we will be drawing shear diagram and lateral load diagram. So this was it.